Bisa dilihat? Okay. Assalamualaikum and very good morning. Ibu bisa dengar atau enggak, Bu?
Bisa. It's good. Yeah.
Very clear.
Excellent. Yeah.
Clear? Okay. So Assalamualaikum and very good morning, everyone. So today I would like to share a little bit about the chemistry in STEM educations that mostly being done in our school, in School of Chemical Sciences, USM. Before I start, I'd like to share one quote, which is "Men love to wonder, and that is the seed of science." So for me, everyone have a curiosity to know something. So actually, the curiosity can create the interest to love or to know about science. So seperti yang Bapak Harry tadi sudah share, what is STEM education, which is STEM can be stand as a science, technology, engineering and mathematics. So as we know, STEM actually can help our young generations to develop their knowledge and also their ability. Other than that, STEM actually can help a youngster to building their capacity, capability, and strength in science, technology, and innovation. Actually, STEM educations can create or encourage our students to release their idea, and actually a student have a very great idea in doing innovations. So STEM education actually can help to the nations itself to meeting our 21st century demands. So STEM skill actually very important because it is the essential for us to meet the challenge. Actually, like nowadays, everyone's into technology. So the technologies, innovations, the advanced scientifics, all these things needs science, technology, and engineering, also mathematics. So without further delay, as we know nowadays, they have a very decreased interest in school students to continue or to pursue their study in science, because they have one perception, which is science is boring. Science is all about the thing that you cannot see sometimes. So the latest report shows that below than 40% levels, students think they want to pursue their study in science. So in Malaysia itself, governments intend to produce more than 60% of the student in STEM field. So as an educator itself, actually we want to encourage or show to the student that science is fun. Science is actually very fun if you explore into it. So since today we're talking about chemistry in STEM, so chemistry actually is a center of science. Why I say this? Because I believe that other field of science like biology, geology, astronomy or physics needs chemistry in their field. So for example, if the student itself want to explore about the astronomy, so modern astronomy cannot be understand without chemistry, which is we need to analyze a spectrum, for examples. We need to understand the periodic tables to understand about the compositions present in the universe, for example. So today, I think Bapak Harry will be more expert than me to talking about STEM. What is how to further the STEM educations like that. So today, I would like to more do a series sessions about the product that developed by our school to reinforce the STEM education, to increase the interest of students in chemistry itself. So they have a few alternatives being made by our school as a alternative to serve the university to engage with the school to establish the STEAM visions, which is the first one is my chem kit. Later I will further explain about this kit. And then the second one is Atomic Frenzy AR. And then I will also share a few STEM program doing by our schools. So let's take a look about the microscale chemistry experiment, which is our school have developed one kit. We call it my chem kit. Why we choose to develop this kit? Because in the chemistry itself, we believe that experiments are a primary components of the scientific method, where students can observe various things. As Pak Harry shared before, we have a 5E into the cycle of the STEM. So experiment is one of the way or alternative to fulfill this 5E. So during the experiment, the students during the lecture, they learn about the theory itself. So the experiments can help students to understand more about the or test the theory, how the hypothesis itself is right, and how physical process work under certain conditions. So we believe that the science lab equipments can allow students to interact directly with the data itself and help to develop the interest in the scientific research area. So since they will do by their own, so they will think that science is fun. Okay, so the chemistry experiments usually, I think, not only in the Malaysia, sometimes, for example, probably in Indonesia also facing this problem, which is we have a very limited lab facilities, and sometimes it involves the expensive chemicals, and sometimes we have a safety issue. So by developing this kit, we believe that the hands-on sessions in class or in the laboratory, it can help to increase the creativity and interest towards science. So microscale experiments offer using a small quantity of the chemicals to undergo or to help to improve the limits of the lab facilities as an alternative, safe and secure laboratory activity. So this chemistry, the microscale chemistry is a combination of the glass and plastic apparatus, and it use very little quantity of chemicals. Alright, so the big concept of the microscale chemistry is seem like this hamburger. Okay, for example, you can see in this figure, we have two hamburger. One hamburger in the micro size, another hamburger is a macro size. Even though they are different in size, however, the content, which is we have a same bread, we have a same tomato, same cheese. This concept being used in the microscale. Which is we still maintain the theory or the concept of the chemistry experiment. However, we do some we create some experiment or some setup experiment in the small quantity. Okay, so here you can see the traditional and the versus of the microscale. Okay, usually we use a very big beaker, a very big conical flask. Traditionally we use in the microscale level, which is we need a large amount of the chemical. However, in the microscale chemistry, we set up the experiment in the small quantities of chemical and using a simple equipment. And you can see in this figure, they have a comparisons. Okay, you can see in the plastic type is a Bunsen burner in a micro size. So here the example of the experiments in the microscale. Okay. So in the microscale experiment is alternative technique to introduce the concept of learning and teaching for the chemistry itself using a small glassware. And actually all the glassware are being produced by our own because in our school we have our glass blowing workshop, so we produce by our itself. So this kit actually can allow the students to conduct the experiments individually. So we hope that when the students can hands-on or conduct the experiment individually, it can increase their interest towards science subject, especially in chemistry. And for the teacher itself, teacher can help the students to understand more about the concept of the certain theory that being taught. Okay, so without further delay, so here is the how the transitions of the microscale chemistry produced. Actually, it's produced around 2015, 5 years ago, by one of the professors in our school, which is Professor Narita. Professor Narita got this idea from the Red Master South African kit. So during this time, they using the plastic type of the apparatus, and by 2016 to until now, they undergoes a few improvements, which is some of the apparatus which is in the plastic, we convert into the glass for longer, so that it can be used in longer lifetimes. And sometimes in the original set, they also have the electrolysis set. However, the original set is very complex. So right now, we already convert the electrolysis set to more simple set, but still maintaining the concept of the electrolysis itself. And we also do some changes in the kit, which is have the clipper and retort stand. And this kit, we also have the kit for doing acid-base titrations. So they have some revolutions for the kit itself. To until now, we have aluminium set. So until now, we have around we have developed the kits, and we have around 3 sets of the kits. So the basic of this microscale chemistry is we want to cultivate the student individual laboratory skill, which is for me, if you as a chemist, is a very important for you to have laboratory skills, which is these skills will be needs and along your career. So microscale chemistry offer the apparatus very simple, cheap, and safe for the student to use. So here the example how small our apparatus in this kit. As you see, the Bunsen burner usually we use in the blue color or in the aluminium side. However, in this kit, we only use a very small glass to fill up with the chemicals, and then they allowed to do the burning sessions. And then for the acid-base titration, we have a retort stand, and we only have usually we have use a pipette around 50 ml. So in our set, we only use around 5 ml. And then for on your right side is about the cation test. Usually we need around 10 ml of the chemicals to observe one reactions for cation. But in our kit, we only use a sheet like at the below, like a bottom's figure, which is this only needs a few drops for the students to observe the test for the cation changes. So my chem kit offer this a few good thing, which is very save time, which is since we use a small quantity of the chemicals, so the reactions can be observed in the shortest time. And then the student can do their hands-on experiments, and it's quite safe, so that we're not really afraid they have some any accident or incidents during the experiments. And also it can become a teaching tools for the student, for the lecturer or teacher itself. And since it's very small, this experiment can be done anywhere, even though in class, outdoor, indoor, the laboratory itself. And it helps towards to grant chemistry, which is it reduces the chemical and waste. So here there's some of the figure that I would like to share. How can our kids very friendly, which is we can use it in the classroom, in the laboratory, and then the student can hands on by themselves, and sometimes we can doing it outdoor. So it's very friendly to everyone. So here the handbook and kit, we have a 3 set of kit of microscale, and then in each kit we give the handbook. So in the handbook actually we have a few example of the experiments. So the experiment actually based on the syllabus in the secondary school in Malaysia. So actually the teachers or the student itself can use their creativity to create other experiment using the same apparatus. So the handbook actually is is like a guideline for them to use and do their experiment. In our latest kit, actually we also provide a little amount of chemicals for them to trial up to 6 experiments. So like Pak Harry shared before, in the STEM we really focus on this 5E, okay, which is engage, explore, explain, elaborate, and evaluate. So in our handbook, we make it easier for the teacher and student itself. We have a flow for each activity that the student and teachers can follow to make their experiment more fun, and also going into the designing new experiments by these 5E attributes, which is in engage, we allow the student to make the connections between the past and present. So usually the student itself already learn in class so that they already understand about the theory. So right now is the time for them to engage the theory and then to explore by doing the experiments. So during the explore, they have an opportunity to practice, to gain the new knowledge and observe some concept, or actually improve their lab skills. And then after they're doing the explore and then they can observe, they can explain to the teacher. So during the explain, actually we give the opportunity to the students, and the teacher who's here actually has a main role to facilitate the learning and during their expert to answer probably some of the observations by the student itself. They're not really clear how to relate the theory and the experiment. So here teachers play a good role to explain more about the concept. And then after they know about the explanations, probably they can elaborate the new experience and concept of the understanding. So by doing this thing, actually they can broaden their understanding on the major concept. And finally, in this kit also, we provide the evaluate in the handbook. Actually, we give a few set of questions. So actually the teachers can use that questions to evaluate the understanding of the students on that particular experiments. So here is the example of the experiments that we have in our kit. Like constructing balanced chemical equations. So I want to highlight this thing, which is the setup of the experiment may differ from the original setup. However, the concept, the observations or the reactions in the experiment will be same. For example, in the electrolysis set, what is different between this electrolysis set with our current original setup is that we use a very small of the electrolysis setup, and we're using a small battery so that it will save more time for the students as to observe what actually happened during the electrolysis. Like determining empirical formula, we still use lime juice so that when the reactions occur, the students still can observe the lime juice turn to cloudy, which is indicate the carbon dioxide release. It's still same, but it's different setup. So our microscale team actually doing many activities to encourage students to have their interest in STEM itself. So we doing the outreach is either with the teachers, with the lab assistant, and also the students. So usually they can try by themselves for each kit and experiments. We also involve in many exhibitions for the STEM program, like Science Week, Science Carnivals. So usually during this time we will be doing exhibitions, and anyone who visit our booth can try by their own for the experiment itself, doing the hands-on session in that exhibition place. Okay, we also involve in sometimes they have a yearly event, and we also contribute in the program. Like for example, Camp Rock is a program doing by our student club in our school. Usually they will invite one school in the northern area to coming to USM, and then experience many activity, and one of the activity is a microscale. And then we also have a yearly event, which is a summer program. Usually we are invite students from university outside Malaysia, like Japan, and since last year we have participants from Indonesia also coming for summer program, but this year we didn't have a summer program due to the pandemic, and inshallah this activity will resume next year. So for example, in this figure you can see they are Japanese students, and all these Japanese students are not on the science background. They are some of them the art background. So we introduce this kit so that they can learn about the chemistry, but in a fun way. We're also doing a CSR program, which is we select a foster school, and then we giving our kit so that their students can learn chemistry. For example, in SMA Ibra, they have a laboratory, but they didn't have a lab facilities. So we believe that by giving our kit to the school, we can help for the students. Before this, they only learn in the classroom, and then they didn't have a chance to doing the hands-on sessions. And then some of the students telling me that they are only watching in the YouTube to see or to observe the experiments. So we hope that by giving this kit to them, they can do their own experiments and experience the labs and develop the lab skill. So far we have a good feedback from our when we're doing a demonstration or exhibitions. They think that some teachers think that this kit can motivate the students to love chemistry, and then the student itself think they more understand about the theory rather than reading the book. So for example, probably this happened when the school didn't have enough facilities to undergo the experiments, and then some of the students itself thinking that by doing their own experiment actually can gain their confidence. So our kit, Alhamdulillah, so far our kit have achieved a few achievement in innovations competitions. We managed to secure gold, and the latest one in the Picture, which is in the innovations of the for higher educations. All right. So for the second product, this product actually developed by my colleague, Dr. Razizi and me. This product actually we didn't test out yet to the school, going to the school, but we just play around with our students to test the effectiveness of the product. So in this product, we believe it's great to make a student have fun with the chemical elements, which is in the periodic tables. But since nowadays students love to play with their handphone, everything, so we add the augmented reality AR so that it can help students to more interest to understand about the elements. So as a chemist itself, we know that periodic tables is a very important because it is organized to provide a great deal information. So as a chemist, you need to know or understand about the periodic table. So our students probably have a difficulty to understand or to memorize the elements. So that we choose to create this, we call it education card. First, education card, and then this education card can help the students to memorize the elements in the periodic table more easily. So the big concept of the atomic frenzy AR, okay, as you can see in the figure, actually is a card of the atomic frenzy. In this card, we shows the name of the elements, and then the symbols of the elements, and then the number of proton for the elements, and then the state and also the type of the elements. On the back side, we also tell the students about the type of the element, for example, the alkaline earth. So probably is very hard for the students to remember the properties of alkaline earth. So we use the mnemonic technique, which is this technique can help the student itself to enhance their memorization skill by combination of AR. So if they only hold the card, they only can see the SR in the red color and also the alkaline earth. However, when they pick up their phone and using a software that we develop, they can see the AR shape on the upper side of the card. Later, I will share the video how the student playing with this card. So the atomic frenzy AR, we think as an alternative technique to help students for them to remember the important information in the periodic tables of the chemical elements. So currently we have around 27 elements we developed for this card. We focus on the main element in the periodic tables that usually commonly used in the chemistry syllabus. So we believe that combinations of the learning technique using AR, education card, and sometimes we can test the students using online games like Kahoot, quizzes, etc. Can help the learning process more effective and fun. Because our aim right now is to increase the interest of the students towards STEM. So since they have the mindset science is boring, so we have to do something to make sure that the learning process is more effective and fun. So the atomic frenzy AR actually the aim as the alternative technique to improving the student memory using AR and online game to make sure is the learning process more enjoyable. Like Bapak Harry shared before, in the Japan they use many alternatives to encourage the students to develop their skill in the problem solving, etc. So we hoping that these teaching tools can help the learning process more enjoyable. So here it is the concept in the atomic frenzy. We also use a different color approach, which is this different color actually represent the elemental group, so that student can more easily differentiate and remember to classify each element in their group. For example, like a sodiums, they read in the they still can remember in the yellow color, so it's alkali metal. So if they hold another card with the yellow color also, so that element in the alkali metals groups. So you can see in this, in here we use a few symbols that the students can easily remember their properties. So here the example how the student can observe during the AR session, which is they can hold the card and then use their phone with the downloaded software, and then they can see on the front side they already see the Na as a sodiums have the 11 photons in the metals as a metals and in the solids. However, we create the electron arrangement which shows the 11 electrons on the orbitals, so that only can be seen if they are using the AR. And then on the back side of the card, before this, they only can see the alkali metal on the card. So using the AR, they can play around and then you can see the properties of alkali metals. So here the examples how the student play with the card. Okay, they hold their phones and then they play and hold the card that they want to remember or to see. So they can see in the card they didn't have the electrons orbitals. However, in the phone they can see the electron arrangements. So here in the other side, okay, you can see and then they can play around and memorize the properties of the elements. Okay. Alright, so in atomic frenzy, AR also, since we play with the phone, so usually when we play with our students, we will using online game to evaluate the learning process efficiency of the students, whether they can still remember what they are learned using the card. Other than that, we also can test to evaluate the student using the same set of the questions, which is in our case, we prepare around 20 sets of questions. So the student will answer before playing the card. And then after they're playing, we use the same set of questions to test or to evaluate the students of what they understand, what they are memorized during the playing sessions. And so far from our observations, they manage, for example, if they answer before playing, they can get around 11 right answer. After they're playing around 50 minutes, they manage to improve their memory, their understanding on the elements. They managed to get a 15 question right. So the improvements around 4 questions right after the playing is quite good for us. So this even though this card we didn't actually test to school yet, but we managed to give or to get a few silver and gold medal when joining the innovations, which is innovations for teaching and learning, and we think that this product have a good opportunity to be pursued in school level. Alright. Other than that, I would like to share around 2 STEM program that been done by our school to encourage or to fulfill the STEM visions. The first one is Malaysia Chemistry Carnival 2018, and usually this carnival will be done by Malaysia Institute of Chemistry. And during 2018, our school have a chance to be a coordinator. So during these exhibitions, we managed to interact public universities, private university, and also private and public sector to join us to do the exhibitions by the aim so that the student have interest in science itself. So we're also doing the innovation and invention competition. So for me, in the STEM itself, STEM, we aim to produce very innovative students. So we take a chance to doing the innovation and invention competitions. We give a theme which is chemistry for environmental sustainability. During this time, we open two categories, which is for school, and also the second category is for prior or diploma, matriculations or polytechnic levels. And during this time, we managed to secure around 20 groups. So the objective for this carnival is to promote public awareness to appreciate science. So we also encourage the students to illustrate the innovative and incentive by the nature of chemistry, and also relate the chemistry with other related science field. And also we want to expose and encourage the younger generations so that they can pursue their interest in science in various field and also the technology. So here the picture during the sessions, and as far as I remember, the number one group, the group that managed to secure number one, they produce bioplastic composites, and this group not only not only produce the bioplastic in their school, they're also doing some testing in the bioplastic, and their aim, they want to commercialize their products so that they can save the nature by using biodegradations materials. Other than that, we also offer the mentoring sessions with the school if they want to go to the competitions. For example, this group actually starting with the STEM program which is doing by our university. They managed to get in the top group, and then they involved in a certain junior water prize in Malaysia, and they managed to get a number one. So they become the representative from Malaysia. So actually initially they're using our kit, our microscale kit, and the problem is they want to produce their own water filter using the flood stations, and then they want to test whether the water is safe or not. So they're using our kit to test. So using that idea, okay, actually during the sessions of the competition in USM, they didn't produce the filter set. They only have the idea and say to us, we want to do like this and like that. And then they make their own prototype using a plastic thing to join the Certain Junior Water in Malaysia. And then when they have a chance to represent Malaysia to Sweden, they want to make their prototype more reliable. So that we offer our expertise to encourage the student itself to make their STEM educations more fine. So we offer our glass blowing workshop make the water filter for them in the glassware, and then they go to the sorting home with more presentable prototypes. Okay, so actually this is my last slide. So what I want to share today, that we believe that by creating, or we as an educator, if we can provide a good teaching tools, actually we can encourage the students to be more fine or more understanding in the STEM program. So So right now, this kit actually is an alternative from our school to encourage the chemistry teachers or lecturers in tertiary and secondary education level, so that they can use our kit as a teaching aid for classroom activity. We also aim that the students can have their own effective fun and learning activity. And sometimes since the kit actually is quite friendly, so parent itself can provide effective and fun learning materials for their children, and all these things can be using in home itself. So that's all. Thank you.
All right, thank you very much, Dr. Nur Farhana.